In this video, we shall look at the following: midpoint of 2 points, length of line segment, gradient of line segment, equation of line passing through 2 points, where a line intersects the axes, perpendicular lines, and the point of intersection of 2 lines. We shall use the points A at 3,1 and B at 11,21. Finding the midpoint. To find the midpoint of A and B, we need to find the x value halfway between the x values of A and B and the y value halfway between the y values of A and B. The x values of A and B are 3 and 11. Halfway between them is 7. The y values of A and B are 1 and 21. Halfway between them is 11. So the midpoint is 7, 11. Finding the length of the line segment. For both the length and the gradient of the line segment AB, it's a good idea to draw in a right-angled triangle, as shown. The x distance is 8, which is 11 take away 3, and the y distance is 20, which is 21 take away 1. Apply Pythagoras' theorem to find the length of the hypotenuse. 8 squared is 64, 20 squared is 400. 64 plus 400 is 464, which is 16 times 29, meaning that we can simplify to 4 root 29. If it seems ridiculous that we might know that 464 is 16 times 29, have a look at the 8 and the 20 we found originally. 8 and 20 are 4 times 2 and 5 respectively. 2 squared plus 5 squared, square rooted, is root 29, which is then multiplied by 4 to give the total length. Finding the gradient of the line segment. Gradient is the change in y divided by the change in x. The diagram shows us that the change in y is 20, 21 take away 1, and the change in x is 8, 11 take away 3. Because the line slopes upwards, it has a positive gradient. So y over x is 20 over 8, which cancels down to 5 over 2. Finding the equation of the line passing through 2 points. We have already found the gradient m is 5 over 2. We can now use the formula y minus y1 equals mx minus x1, with either a or b as x1, y1, to find the equation of the line passing through A and B. Let's use A because the values are smaller. We shall write the equation in the form ax plus by plus c is 0, where a, b and c are integers. So y minus 1 is 5 over 2 times x minus 3. Doubling both sides, we get 2y minus 2 equals 5 times x minus 3. Multiplying out the brackets gives us 2y minus 2 equals 5x minus 15. Bringing all the terms to the same side, we get a final equation of minus 5x plus 2y plus 13 equals 0. Note that we could also have had 5x minus 2y minus 13 equals 0. Finding where a line intersects the axes. We have already established that the equation of the line through A and B has the equation minus 5x plus 2y plus 13 is 0. The line intersects the y-axis when x is 0, so we get 2y plus 13 is 0, and therefore y is minus 13 over 2. So the point is 0, minus 13 over 2. The line intersects the x-axis when y is 0, so we get minus 5x plus 13 is 0, and x is 13 over 5. Hence the point is 13 over 5, 0. Finding the gradient and equation of a perpendicular line. If a line has a gradient of a over b, then any perpendicular line will have a gradient of minus b over a. So we reciprocate and change the sign. The line through A and B has a gradient of 5 over 2, so any perpendicular line will have a gradient of minus 2 over 5. Let's find the equation of the line perpendicular to AB, which passes through 10, 3. We shall use the formula y minus y1 equals mx minus x1, with m is minus 2/5, x1 is 10, and y1 is 3. So y minus 3 is minus 2/5 of x minus 10. Timesing by 5 gives 5y minus 15 equals minus 2 times x minus 10. Multiply out the brackets and rearrange, and we get 2x plus 5y minus 35 equals 0. Finding the point of intersection of 2 lines. Finding the point of intersection of 2 straight lines is the same as solving 2 linear simultaneous equations. For example, where does the line through A and B intersect the line y equals 2x minus 4? The line through A and B has the equation minus 5x plus 2y plus 13 equals 0. We could make y the subject and put the two equations equal. In this case, it is probably simpler just to substitute for y equals 2x minus 4. So starting from minus 5x plus 2y plus 13 is 0, we get minus 5x plus 2 lots of 2x minus 4 plus 13 equals 0. If we multiply out the brackets and simplify, we get minus x plus 5 is 0, so x is 5. Substitute x equals 5 into y equals 2x minus 4 to get y equals 6, and so our point of intersection is 5, 6. Thank you very much.